So today I'm going to talk about the QC development that we at the UK Stem Cell Bank did for the EBiSC project. So you've seen the current standard cell line processing, and the one that we did a huge amount of work on was quality. So like Kevin mentioned earlier, there's specific batch release testing for cell banks. So things like mycoplasma, viral screening, growth of microorganisms, viability, cell line identity, these are the essential ones that have to be passed. And the method is listed there, and the time point also, and the exception criteria. So obviously for things like mycoplasma, growth of microorganisms, not detected is the criteria. Viability, you want the cells to grow post-thaw, and cell line identity must match the donor. The informational tests are the ones that are just to add more value to the line. So we look at things like morphology to make sure that the cells look like typical iPSC lines. There is flow cytometry performed on the cells, so SSEA4, TRA160, OCT4, SSEA1. Again, there's only alert limits, so obviously if you're outside specific ranges, then you might have to take a look just to make sure everything's okay with your cell line. Karyology at the moment, we're using G-banding, pluripotency assay, which I'm going to talk a bit about after this. So we use an EB assay, and vector clearance is with PCRQ pre-bank, and just to make sure all the vectors are silenced. The one that Kevin spoke about briefly as well earlier was about, obviously when EBiSC started, we didn't have any gene-edited lines coming in. So obviously that had to be taken into consideration. Like I said, the question was asked earlier about, are you checking for genetic lesions? And obviously, ideally, you do. And also, you would look for vector clearance as well. So we spent a lot of time looking at pluripotency assays and how to try and improve them, make them more robust and cost-effective. So the first assay we looked at was a spontaneous EB assay. We looked at 24 genes, 2 time points, and 3 biological replicates, and these were measured by qPCR. And we found out that all cell lines showed a decrease in stem cell markers and an increase in gene expression markers for each germ layer. So for this experiment, we looked at 29 of the first hot start lines, and these are the lines that had come in from different universities across Europe. At the UK Stem Cell Bank, we use H9 as an internal QC for assays and things, so we already had the data available on that, so that was a good control also for this assay. So just to show you on the top here is just a typical iPSC line, so here it is, and there's an EB at day 7 and day 14, and on the bottom is the same for the H9. So what we were able to generate from all these lines was a reference CT value once you normalized all the cells, and you can clearly see that you get quite a nice pattern for stem cell markers and for the other germ layer markers when the cells are undifferentiated. And why this becomes useful is then you can use this and you can put in so a NIBS 8 line, an iPSC line, and you can line it up across, and you can see that if it falls into the same pattern, that your iPSC line is undifferentiated and looking quite good. And just to show you the inverse of that is if you look at an NPC at day 12, these come up, you can see that all the CT values fall outside, and you can clearly see that this line is undifferentiated. We did some PCA analysis on the undifferentiated cells as well from across the different groups to see if we could see any trends or any grouping. And it was mentioned earlier as well, the biggest kind of trend that we identified was that it was from lab. And also if there was any clones, so for example, we had 3 binary clones, and they all grouped as well. We couldn't see any way the reprogramming method, because these all vary in how they were reprogrammed. The starting material seemed irrelevant, so some of these are blood and some of these are fibroblasts, and it didn't seem to matter if they were diseased lines or from healthy individuals. So once you run the assay, basically what you get is a readout like this. So you see the the relative gene expression to the undifferentiated control for all of your genes across the germ layers and your stem cell markers. When you put all the data together, you're again able to build one of these quite useful sets. And you can again see that there is increased gene expression for lineage-affiliated markers for each germ layer, but also we found that there was some genes were more robust, and this enabled us then, so I just highlighted the ones there that were more robust, basically means you can cut down the amount of markers that you use for the assay and still retain all the information that you want. So like I said, when we looked at all these lines, they were all pluripotent, but what we did notice was that you were getting obviously different patterns of gene expression. So the question that we asked was, can we infer any cell line bias for particular lineages when using this assay? So the approach we took was to define this ranking method to assess the lines in terms of their lineage preference. So the method that we went about was, what we did was we normalized the CT values using ACT-B, summed the CT values for the genes within each germ layer, calculated then the global germ layer associated CT value, and then we were able to rank cell lines in a preference bias for each of their germ layers. And what you end up with is data like this, where of the lines that we looked at, we could see that, for example, this Hubrick line scored the highest for endoderm, mesoderm gene expression markers, and this line from Bonn ranked the highest in terms of its ectoderm markers. So we were able then to basically group these cells into 3 different groups. So the first group that we identified were cells that showed kind of no predisposition towards any specific germ layer. They kind of scored pretty evenly across all lineages. Then there was a very distinct ectoderm predisposition. And the Bioneer lines were the ones that kind of fell into this one as well. And then the third group was an endoderm mesoderm predisposition. And the interesting thing about this that we found out, even though we used completely different sets of genes for each germ layer, that they ranked almost identical in how they scored, which basically means that in this system we couldn't really say if they were stronger for endoderm or mesoderm. And then when you PCA them, you can actually see that there are 3 quite distinct groups. The one up here being the ectoderm one. These are the ones that scored in the middle, and these are the ones that appear to be more endoderm mesoderm bias, if you want to call it. So then the question we want to ask is, well, can we predict then from undifferentiated cell gene expression patterns how these cells are going to behave if you differentiate them in this system? So this is the day 0 PCA undifferentiated cells, and you can see we've now put the cell lines into their different colorings, and the answer is not really. In terms of, I mean, the Bioneer ones are all up here and grouped again, but you can't really see it with this. So can we really predict how they're going to behave at day 0? No. Just to summarize what I just went through, all these cell lines that went through the EBiSC hot star process demonstrated potential pluripotency in this assay. Cell lines appear to have a bias towards a specific lineage. We can see this at day 7, but we can't see it at day 0. So the questions that we would ask going forward is, if you put these cell lines through a directed differentiation type of assay, what kind of bias trends, patterns might you see? And should something like this be considered when choosing a line if you're going for specific cell types? So for example, if you wanted to make neural lines and you went on the EBiSC catalog, would you be better off picking, for example, the Bioneer lines, which have a very strong preference to make ectoderm? And yeah, would a biased cell line be more efficient at making cell types within that germ layer? We haven't tried this yet because obviously this was beyond the scope of what we were doing for this work package. But that is a question that I think we would like to look into as well. So I'd just like to finish by thanking everyone at Stem Cell Bank, particularly Charlotte Chapman, who's done a huge amount on this project, and to all our partners in EBiSC. Thank you.
Thank you very much, Orla. So, any questions? There's a question over there.
Hi.
Hi.
That was really interesting. So what you see is that like the different cell lines are having different kind of capability to go in one direction or in another when you go through the differentiation. So of course, like, you know, they are just growing in the standard conditions and whatever, but what you don't know basically is what is the epigenetic kind of profile that they're showing. So I'm particularly intrigued in this kind of direction because what I'm working on is actually the potentiality of the cells associated with the bivalency of the genes in stem cells. And so like what it looks like is that these modifications are kept also through the differentiation. And one of my big questions is about trying to understand, for example, if the different presence of genes or pool of genes that are showing this kind of differences could be associated with the potentialities. So are you running any experiment in the direction, try to characterize them?
No, because originally we were just running this assay just to check you know, basic pluripotency, but once we started getting all the data back, we were like, oh, you know, there's a huge amount going on here. And once we started to look at it, then we started seeing things and answering all these questions. So that wasn't the original plan, but I know what you're saying in terms of that. That is very interesting. And I said, we only looked at, it's only 24 genes we're looking at here in terms of all these things. And even at that level, you can still see that the cell lines group together, and yeah, they differentiate in completely different ways.
The funny thing is that just the genes that we are looking at are exactly a target of the modification that I'm talking about.
Oh, okay.
Maybe we can discuss about it later.
Yes, absolutely, yeah.
There was another question, yeah.
Orla, were all the cell lines in a standard, consistent culture system when you started the assay?
No, so this is the thing. So we grew them in what they came in, but they were either in E8 vitronectin or MTs or matrigel, basically.
Any sense of whether or not the culture platform they were in
So we
influenced the
looked
fate
at
decision?
that. Yeah, we looked at that, and it didn't appear to have any effect that we could see.
More questions? If not, I would like to thank again, Orla.